Hello everyone. Last classes we have seen about the transformations of 2D and 3D of different categories we have seen in the CAD modeling. So here the next chapter of the second unit is the geometric modeling. So in geometric modeling, how the need is presented. So first, what is the idea of the design engineer? What are the concepts he is going to put in the design analysis? So how it is going to integrate the data to the production team? So the concept of integrating these three is our geometric modeling. The whatever the concept your design engineer is getting, he is going to put in the form of the ideas. These ideas will be created in the form of drawings, sketches, and some representation to the other people. These ideas are put together in an engineering concept of the drawing, and you are going to create the machine drawing or production drawing. What are the features you are going to create in the 2D or 3D forms, and put all the material properties, the design processes, the data, everything are put together and analysis is done. These analysis is after structural, thermal and other analysis are done and going to be created to the required data, and this will be represented to your production team for the further manufacturing process. So it is our geometric modeling. What are the data available in our geometric modeling? So it may be a two-dimensional representation or it may be a three-dimensional representation. The two-dimensional representation means it is a line or circle or square, rectangle. A line feature will be there, only the area will be created here. If you are going for three-dimensional, you are going to create the volume of your object. So how you are going to represent the 3D dimensional objects? We can represent them in the three forms. One, with the line skeleton line object representation, we call them as wireframe modeling. Next comes under your sheet metal, how to represent this sheets of the metal paperwork like this. Then we call them as surface modeling. The surface of the objects will be seen here. Next comes your solid modeling. So how the 3D object is represented. It may be in an orthographic view or in a perspective view, or it may be any other representation how the customer needs. So these are the representation done in our geometric modeling. So here comes your line model, your surface model and the volume model. So you can see your first diagram, line model. So line models, they are made up of lines which represents with end points here. So we can see the point P1, P2 like this, how many points are there? These points are plotted and it is the data which is considered for a line L1, L2 like this. So if P1 and P2 is making the line L1, so how the object will be considered is only the line will be considered with the edges of points. Next, if you go for the surface models in the second diagram. So here you can see surfaces are made. So they are made with the lines integrating together. So you can see the surfaces made up of sheet papers or sheet metals here. So that the hidden objects you cannot see the where it is here backside behind the sheet here. So you can see the surface S1, S2, S3 or this is like as you are making a model with the papers. Next comes your volume model. So you can see one cube and the other cubes are joined together to make your required object. So a similar objects, that is shades of solids are integrated together to get your objects obtained. So this is your volume 1 and volume 2 for this model. So how you can going to represent your wireframe modeling? You can see the diagram, the first diagram shows you the lines that are made up of sticks. Okay, so you can see the wires, you are making an object with a wires or stick model. So like this you are going to get your wireframe model. So for this each and every lines are made up of points, vertices, edges. Okay, so you can see the first one table is your edge table. So edge 1, edge 2, edge 3, they are made up of vertex. So vertex is the points. So it may be made up of 2 points makes one edge, a line. Okay, so these are the next. How the data is stored? The data is stored in the form of first is edge data. Then comes your edges made up of vertex data. So the points are stored. So the memory for storing this data is going to take it in a bigger one. So here comes the advantages of your wireframe models. It is very simple. The memory is very less because only points and lines going to store. So inside here it is hollow, there is no data, pixels are occupied here. So the memory occupied is very less here. So it forms the base. If you are going to create a surface or any solid model, first you have to draw your sketches, wireframe. So first you are making the model, so this is very simple, less memory, and it becomes a basic for creating your surface and your solid model. So for any calculations, if you want to give for area or line, then we going to consider a simple calculations can be done here. Any more editing can be easily done here, but we cannot go for any density, volume, space occupy and all. We cannot do with this model. So this is the disadvantages. So you can see that limitation, because it is very limited to only simple sketches. So ambiguity is very less. So by viewing we can just change the view and we can see them, but we cannot go with a perfect one, because the rear side objects also will be seen in the front view. So the complexity of viewing becomes a problem here. So actual representation is not available, whereas it is made up of many lines here. So your model becomes a complex. If you are going for the complex curved surfaces, many number of curves will be seen in the view. So it will be a disturbance. So your clarity of the image is not obtained. So your actual solid, how it looks, cannot be represented in this line diagram. Okay, so by calculation of the mass, surface area, volume, center of gravity, it cannot be calculated in the line diagram. So if you want to calculate all these things, we need to go for surface or solid objects. So you can, if your wireframe models, it with a simple face only, so you cannot go with the surface how it looks. If any curvatures are there, those cannot be represented. So you cannot detect the interfaces in between, any mating components cannot be drawn here. So this, you cannot use it for your NC tool or robot arm simulations. So now here comes your surface modeling. So surfaces, it is a sheet metal works or paper works if you are going to use them. So we are just making the points. These are called as control points. These points are joined with the control polygon. Polygon is a line that joins your control points. So according to the direction of your control points, you are just making your diagrams to load. For example, your small kids will be drawing the plotting the small diagrams will be there. They will be giving the numbering of the points and will be joined 1, 2, 3, 4 like this, so that they will be joined together to form your required drawing of the sketches in your cartoon features. So like this, you are having number of control points. You are joining all the control points with a control polygon to get the required shape. So here it will be used for your main surface with your automobile car body making of the different profiles are made here with the different sketches, aerodynamic shapes here, so that the shapes of the front panel, rear wing sectors easily can be obtained. For aircraft wing designs and all, these are made up of sheet metal works. So these will be done with their control points. So these are going to give a shape model, not the line model. So here it is ambiguity compared to wireframe, you can see here. So the hidden lines cannot be seen at the back. So here you can see the wireframes, you can see the hidden object, but here hidden lines are not seen here. So better visualization, presentation is very good compared to your wireframe. We can use your CNC or your robotic program can be easily obtained by getting your 2D plane, not your 3D plane. So the geometry for your manufacturing engineer, for making your molds, die designs, it helps a lot. But when you're going for your volume calculation, this cannot be. Only negligible thickness, we can have it here. So when you're going for complex free-form shapes like ship hull, aeroplane, fuselage, and in the automobile fields, it plays a very good role. So roughness, the color, the material property, the shape, the shiny appearance, everything can be easily demonstrated when you are explaining about your sheet metal works. What are the disadvantages? So I have already said you, only the exterior object sheets only can say, interior if it is a solid block, if it is made up of, if you say if it is a cardboard box, we only thick cardboard only we can assume. Inside the block, we cannot calculate. So if any curved weaves, any fine meshes, we cannot go for very high accurate level. Is compared to solid, this is less. Okay, so if you may go for coarse meshes, the fine meshes means very small thing, meshing lines. So if you are going with a coarse means the distance between the control points, that is called as mesh. Okay, the complicated computation you can have for number of surfaces you can add, then only we will be going for complication or any complicated diagram if you want to produce, then we go for number of layers has to be produced here. Now comes your solid modeling. So solid model, so you can see it is a volume created with a number of surface layers created here. So by visually we can see and you can understand what is the perfect object looks like. So weight concentration, mass, your gravity, your volume, density, everything can be easily analyzed with this solid model. So what are the advantages? So So here you can go for calculation of your area, volume, weight, center of gravity, moment of inertia for any object, rotating object, moving object, mating of the two components. You can easily understand and represent in a very faster, and you can calculate the analysis also. So any design engineer, he mostly go with the theoretical model as well as this analytical model. So the ambiguity level is somewhat very high when you are comparing with your solid models. So here the FEM programs, that is finite element analysis, using your ANSYS, you are doing the structural, thermal, CFD analysis, your crash analysis in your automobiles can be easily done when you are exporting your solid model from one to the other analytical software by using your IGES format. Or otherwise you can create your solid model, and if you want to go for 3D modeling, we can just create your stereolithography by STL format, and you can format from one format, you can just exchange the data to another format by the common databases. So here comes, you can use your SIM, that is computer integrated manufacturing, computer aided manufacturing, means robotics, your production lines, your automatic machineries, everything can be easily used with these techniques. Okay, so design for manufacturing. This is your designing your manufacturing, selection of the tools, selection of the material, your scheduling, routing, and your processing, everything can be easily analyzed here. So your 2D drawings can be easily converted to 3D drawing, or 3D drawing can be easily viewed in the form of 2D drawing by having your orthographic view or any other view, how you want to represent can be easily represented in this solid model. So what is the disadvantage? In compared to your wireframe and your modeling, your computation we have to calculate, but more intensive, it occupies more number of data, memory space is occupied, and the faster becomes, this quickness becomes slow when compared, because the processing speed is required. So for that what we need a very high powerful computers with a faster processing and a high memory space is required when you want to go for your modeling, when you are doing your solid modelings. Okay, so what are the modeling facilities available when you are going for modeling? What are the things you can do in your solid modeling? Means geometric modeling, you are going to go for features, so you can just go create your geometry models, and you can just go with the editing. If you want to change your editing, change the size, or if you want to move your object or rotate an object, give any color codes, material properties, we can easily make them. And you can just make a display control, zoom in, zoom out, pan, you can just have your visual effects also can be added here, so you can control your display how you want to give. Next, your drafting facility, means your drawing facilities. So you can just draft how we want to make your virtual view, how we want to make it your representation. Or it may be a catalog view, or it may be a exploded view, or it may be any production drawing. Okay, these are things we can see in our drafting facility. So the programming we can just convert from one to the other. So analysis feature also can be easily done here. So I can connect the features from one software to the other chapters easily. Okay, so this is what we are seeing in our this class, modeling facilities. Okay, so further we will see about how modeling is done in the next class. Okay, thank you.